Good morning, students. I am Professor Manohar Kodmelwar, Assistant Professor in Computer Engineering Department from TSSM Bhirabai Sound College of Engineering and Research, Nare, Pune. So today we'll discuss about the high performance computing practicals, which are in the laboratory practice 1. So today basically mainly we'll study about the particular bubble sort algorithm, right? So we can see that from this PPT, that problem statement implement the parallel algorithm for bubble sort. That is what we are going to implement. Parallelism we are applying in the bubble sort algorithm. The objective is that we will come to know the parallel algorithm for bubble sort. And when this particular learned by the students will be able to understand that we can apply the parallelism in a bubble sort algorithm. So some of the points related to bubble sort algorithm, what we are going to do in this. So user will give the number of elements which we consider as unsorted and which will be accepted by our program. Then what we will do is that we will compare this adjacent two elements, pair of adjacent two elements, and if according to the value we will shift left, that if it is the lowest, then we'll shift to the left, and according to that we'll swap it. So for swapping this, we use the swap function, and this checking and swapping functions, these two functions will run till the all elements will be sorted. Once these all elements are sorted, the sorted elements we will display in the output section. So from this PPT or from this slide, we can understand that I have arranged this 0 to 5. The particular 6 elements are arranged in the 0 to 5 in the column fashion. The unsorted elements we have took here, that is a 5, 6, 3, 4, 1, 2. And once we will apply this particular unsorted numbers to our bubble sort program, you will get the sorted elements as output as a 1, 2, 3, 4, 5, 6. So this we can see that these two elements are pair of two adjacent elements are checked, and according to that the swappings will happen till the end, that you will get the sorted elements. From implementation point of view, we can see that there are basically two functions are most important, where it is one is a bubble sort, where you are going to check it, and once you check it, second thing is that you are going to swap it. So these two functions are most important we can consider in this. And another thing we can use is that this pragma open parallel for shared memory. This is the most important line we can find in our program. So it will run that particular code below whatever code we write. That code will run parallelly. So from here our parallelism will start. So we'll see that which function has to be where we want to make it parallel. So this hash pragma open parallel for shared memory will use it in our code. So we are writing this particular program, bubble sort program in C++. So let us see that how this particular code will execute for the unsorted elements, and we'll get the sorted output. So let us write and execute this particular code. So let us write the particular bubble sort program. Hash include iStream for input output. Then next we'll include the standard library.h header file. Then now important is that OMP, very important. This particular hash include omp.h So it will access all multi-program related what you can say details or inputs from this omp.h header file. Then by using name space standard, this will use it so that standard definitions will be available for us in namespace. Then we will use void view bubble int star comma int with the two integer arguments. We'll define this. It is the declaration of bubble sort we can consider. Then we will use another which is most important function, that is a swap, having its own arguments. Sorry. Integer. Right. So now this swap function we will use for swapping the particular elements. Here we have declared these two functions, and from actual definition we will write, actually we have to write actually main before this, so that we can understand how this particular main function which we can use in our particular program, right? So before going into the main function, let us will see that how we'll write this basic these two main functionalities. After that we can write this main which will call the particular these functions. So let us write particular main functionalities like void void bubble int star a, then int we can consider as the elements we can show here. Again is the number of elements. Then we write the basic code for int. I will take the variable integer I equal to first initialize to 0. Then I am going to check this I with the particular n, the number of elements. Then I plus plus we can consider for increment. This is a completion of for loop. For n elements we have written the for loop. So here you are going to check it. Then here we'll write the int. We'll declare one variable, that is fi rst first equal to I %2. So this statement is most important, so that the value of whatever module, what you can say mod functions we are using here. So whatever the value of first will come, that will assign in the for loop, and according to that the numbers are selected for each iteration. So this is a most important statement, that is a I mod 2. So for example, if it is a 0 mod 2, we will get the 0. If it is a 1 mod 2, we will get 1. If it is a 2 mod 2%, then we will get the 0. So like this will take the output of this first and we'll assign it to the particular loop in the loop. So this is an important statement that we have to understand. Then after this, what we are going to do is that we are going to execute the bubble sort in the parallel fashion. That is now here our start pragma OMP parallel for shared memory. We'll take the elements as a comma f hierarchy first and n we can consider number of elements, right? So after this we will write for the for the loop will inner loop will write which we are going to execute parallelly. So by this statement pragma OMP parallel shared memory, now below this code what we write, that is it will executed in a parallel. So here processor will get the number of threads, then we'll write the for loop integer I, or we can already we have to die, so let us take some another variable like j, integer j equal to, we'll assign the value first to this j, then we'll check that if j is less than n minus 1 for the number of elements, and then j plus equal to 2. So here we have took the j plus equal to 2 so that it will take the what we consider a pair of two adjacent elements, right? So if so this is also most important, this statement j equal to j plus 2 instead of so we have to write this particular for loop inside for loop. Now here we'll write if loop which will check that whether the two a pair of adjacent values are equal, greater than, less than. So for that we'll write the code here, a of j is less than a of j plus 1 if it finds. So what we have to do is that we have to run the swap function. Here we will write that if we find that a of j is greater than a of j plus 1, then we have to swap this particular value. So we'll run the swap function, swap a of j a of j plus 1 right. So this swap function will be used. If it fails, automatically again it will go to the next values. So right. So this is the most important function we have to write. We can consider swap function, right? Now after this swap function, we'll close all curly brackets which we have used. These curly brackets are most important closing, otherwise it will give the error after writing the code. right? So this is the most important bubble function we have written, where this will run this particular code for we can consider as swapping. We will use this. Just we will check it and swap it. So for this swap, we have to write the swap. We can consider the swap function. So in swap function, we can see that we'll write one swap function. This is divide swap integer ampersand a comma integer ampersand b. So according to the number of arguments we have shown here, C integer ampersand and integer ampersand, we have took the integer a and integer ampersand. So ampersand will show the, we can say, addresses, right? So now we will write the code for this. These two important functionalities are more important in this bubble sort. So here I will write integer, some variable I will declare test. Then here the actual swapping will happen actually in this code, that will assign this test equal to a, and we'll assign a equal to b, and we'll put that particular value into the b. So this is the most important. These two functions are more important in our code. Here the swapping will happen, right? So a will go to the test, right? Then whatever value of b we set send into the a location, and whatever test value is there, that will which we have inserted, that is a, that will shift to now b. So now here swapping happened, and lowest value is now shifted into the a, and highest value shifted into the b. Now our swapping is over in this small code. So we have closed the curly bracket. So these two functions are most important. Now another we know that there is a integer main or void main we have to write, and from void main we'll call this bubble sort, and we'll accept the numbers. We'll call this bubble, and the bubble will call the swap, and you will get the particular output for this. So let us we'll see the integer main. Now let us see that. So here we are in the particular directory where our particular program we have coded, already typed, that is we have stored in the bin directory. So it is advised that whatever programs you will write, you have to store in this particular bin directory, right? So now we'll execute our program for this particular bubble sort. Right now we are in the directory of our particular bin directory, you can consider, where our all files are stored, right? Now what we will do is that whatever programs we have written till now, every program will store into the bin, and from that bin we will execute it, right? So we have one function, or we can consider the command for executing this particular program. So here I will write the code for this: G ++ minus F open MP B bubble sort. We have stored this particular file, whatever we have coded in this particular, the name we have given bubble_sort.cpp. then minus O, which shows the output file, and this exec will give you the output. So let us wait that the compilations is going on. Compilation is going on. Once the compilation is over, if any errors, it will display. Otherwise, it will directly show the particular execute that file. So exec will execute it. So now it is asking the total number of elements. Now we'll take the total number of elements as 6, and we will give the total number of elements like 4, 2, 8, 3, 5, 4. So now we can see the output that you are getting 2, 3, 4, 4, 4, 5, 8. So it is a sorted, right? So like this, our particular bubble sort will run. Now let us try for another inputs also. Let's see. Let us take the 5 numbers. So here in 5 numbers, we'll take 3, 2, 7, 4, and 9. So we can view that 2, 3, 4, 7, 9, which is sorted. So like this, our bubble sort program will execute by using the parallel programming technique. So thank you, students.